volume of a prism right on your reference sheet, BH. Now, it does not say what each variable means, so let's make sure we know what each B and H mean. Capital B, that's going to be the same capital B we talked about in surface area, I believe, of a pyramid and a cone. That's the area of the base. Okay, so whatever the shape of the base is, you find the area of it. And then H, I think we could probably guess, but just make sure we're good. That's the height, listen, hey, of the prism. Not the height of the base or anything else, height of the prism. And remember, the height always connects the bases. All right, so whatever edge connects your bases, that's the height of the prism. All right, go ahead, look on your reference sheet again. What about volume of a cylinder? It's still BH, except the B is a circle. Everyone see pi r squared now instead of B? Yeah, that's because the base is a circle. So pi r squared, but still times the height. All on your formula sheet. No reason. Oh, you think I got fired up yesterday when you didn't know your formulas on your quiz? It's on the formula sheet now. All right? No reason. All right, ready to get into it. Because this is why I think this second half is pretty tough. I'm going to do like one of these with you. Oh, here's your shape. Find the volume. Right after that, boom! Word problems. All right? Whole bunch of word problems this section. All right? Very little, oh, here's your figure. Let's find the volume. I don't care. I want to do word problems with it because that's what we'll see on the Regents next month. All right, so what am I looking at here? What is this? Talk to me. Name this thing here I got up. It's not a block of cheese, that's for sure. What do I have there? What's that bad boy called? 8. Sophia, what's that called? Triangular prism. I heard the word prism from you, so I know it's going to be BH. Here we go. What does B stand for again? Remind me. 10. What's the B stand for? Area of the base. What shape is the base? Triangle. All right. So I'll go off to the side here and do it. I don't want to confuse you by writing it in here. So the base is a triangle. We all know triangle formula, 1/2 BH, right? I'm just solving for big B right now. I'm solving for big B. All right, everyone I'll highlight it up here. Take one of those triangular bases. And it's a right triangle. We know something about the base and the height. What's the base and the height of this right triangle here? Here we go. 7.
Like 8 and
15. Yeah, that's correct. Yeah. Because remember, when we have a right triangle, base and height, 2 legs. Right? 2 legs. It's already there. 8 times 15. So big B, the area of the base, before I plug it in. What is that? Anybody? 60? Yeah, that is 60. All right, so 60. So I go back here. Big B is 60 times. Now what's the height of the prism? Make sure you know that H represents the prism. So what edge is connecting the bases? That's what you look for. Where's the edge that connects the bases? 5? 8. Yep. There we go. There's our volume. So what are we looking at there? 480. Some of you guys I've seen on the quiz like to put units, which I'm fine with. Be careful that we're doing volume now. Volume. So now this is cubed. All right, so units are cubed when you do volume. Any type of area, it's squared, but volume, it's cubed. All right, that was fun. Any questions? Ready to do some reading? Left to right, put them together, forms a sentence. Ready to roll? Oh, we got a rectangular pool. 1,080 cubic meters. Okay, can everyone just stop here? Do me a favor and circle cubic meters for me. Now, I already said it's the volume, so there's no guessing game. But if I take that word volume out, that also tells you we're talking about volume. All right, the fact that that's cubic to the third meters. All right, that so if I take the word volume out, I know that 1080 is still volume because of cubic meters. Length, width, and depth are in a ratio. Whoa! Come on now, we're in June. We're almost to June here. What do we do with numbers in a ratio? Because I know I'm going to put them in an equation, but I can't just put 10, 4, and 1 in there. I got to do something with them before I put them in the equation. 13. What have we been doing all year, Charlie? Darn right. Been training beasts all year long here. Find the number of meters in the 3 dimensions of the pool. All right, we don't have to draw the pool. Length times width times height. All right, length times width times height equals the volume. All right, but now I might be training beasts this year, but I need to send beasts to Algebra 2 next year. All right. Or Miss Lynch next door is going to be in my grill. What kind of kids did you send me? Just like that. That's what I hear when she talks to me. 10. So what are we doing with these 3 here? What do you get when you multiply them? Who's going to dig deep here for me? 10x times 4x times x. Make sure we're multiplying, not adding. Don't give me 15x. 2. Yep, good. Yep, thanks. I got it. 11. Uh-oh, here we go. Come on. X, X, X. There you go. Okay, got to add the exponents on the x. So 40x to the third equals 1080. What?
Can't you also like add them all up and then divide them by the amount? Then whatever that is, multiply that by
Add them all up.
like 15x, and then divide that by or 1080.
Why would I add them up?
Because it's like the total ratio.
Well, let's see if we get the same answer at the end.
Okay.
Okay?
Yeah.
What do you think your next move is? Thank you. Divide by 40. Everyone tries to do something crazy with this to the third, but you can't until it's all by itself. So unattach that 40. And we get x cubed equals, what's that number? 27? All right, look, if that was squared, everyone would say, oh, take the square root, take the square root. All right, well, it's not. It's to the third. So instead, I'm going to take what's called the cube root. And maybe I've talked about this during the year. If we have, it's been a while. So in your calculator, if you go hit your math button, if you hit the math button on the left side, you'll see cube root number 4 probably. It's all right. No need to get nervous. I know it's a new button. It's exciting. Cube root of 27. There we go. 3. Is that what you got?
No.
So your idea, forget it. I could have probably told him that from the beginning, Nate. But I gave him some hope. So x equals 3. It doesn't make us a winner though, right? Find the 3 dimensions of the pool. Got to take x, plug it back in. Right? It said find all 3 dimensions. So 1 dimension will be 3. What do we have? Meters. 3 meters. 3 times 4, 12 meters. And 3 times 10, 30 meters. So there's your 3 dimensions of the pool. Everyone all right how I got that? I took the 3 and plugged it back in for 10x, 4x, and x. We all good? Before we start filling up a tank here? All right, let's do it. Jed. There's a new name for us. All right. But a generator runs 2 hours on a liter of gas. There's the dimensions of the tank. I'm going to fill it with gas. How long will it run for? And I give you a little conversion here. Because look, everyone see how the dimensions are in centimeters? But I need to know really, because it runs 2 hours on a liter of gas, so I need to know how many liters are going to be in here before I tell you how long it can run. So here's the conversions from cubic centimeters to liters. So let's find the volume first. All right, I'll get my answer in cubic centimeters, then I'll try to convert it to liters. And this is what the second half of the unit deals with. A lot of conversions. How do I find the volume there? 12? Yeah. Yep. Or it's when we say length times width times height, we're doing BH. Right? Aren't we just doing BH? Base, length times width, 15 times 20, and then times the height, 10. We're still doing length times width times height with BH. All right. How about that volume when you have it? What are we looking at there? 13. Charlie, what do you got for that volume? Got it. So 3,000 cubic centimeters. It runs 2 hours on a liter of gas, not cubic centimeters, a liter. So now we need to convert 3,000 into liters. If you're unsure what to do with that 1,000, just like I suggested last unit, make a proportion. You ready? 1,000 centimeters cubed equals 1 liter. I write the conversion, and then whatever I have, I put it with the correct units. So I have 3,000 cubic centimeters. I put it with the cubic centimeters, and then I put X over the 1 liter. How many liters do I have? And then you guys can cross multiply and find out how many liters I have. So write your conversion and then make a proportion out of it if you're ever concerned. How many liters am I going to have here? 10. How many liters of gas? Yep. Cross multiply, divide by 1,000. I'm going to have 3 liters. All right, let's answer this question now. The generator can run 2 hours on every liter of gas. So we have 3 liters. How many hours now can it run? Okay, 1 liter gives it 2 hours of power. How many hours are we going to have? 1, Anna?
6 hours.
6, right? 2 times 3, 6 hours. This is where we are, guys. Sorry. Actually, I'm not at all sorry. I'm lying. This is where we are. Find the volume and then do some conversions after. That's where we are. Spence, you good with that?
Yeah, good.
Darn right you are. All right, I just got a cylinder. What's the volume? Go back to the reference sheet if you need it. Here's my cylinder. What's the volume? Pi r squared h. Read through the problem. I ask somebody what each piece is here. What's my radius here? 12. What's my radius? 5, right? Half of 10. 5 squared, and everyone can read the height is 7. Leave your answer in terms of pi. Everyone's leaving that bad boy right there and calculating everything else. All right, let's do something with, oh, not yet. 12 again, what do you got in terms of pi?
175.
Yep, 175 pi. If you guys are doing units, make sure it's cubed. Make sure we're cubing them. All right, again, That's the only problem we're going to do like that. Let's do something and whip the cylinder down. Oh, thermos. Anybody still bring thermoses or use thermos seriously? Bring thermoses to school? No, not at all. With the flip top? No. Anybody ever have the lunchbox that had the thermos in it? It was like a character lunchbox. Yeah, those are good days, weren't it? You just have one of those too. The metal ones. Open it up. The little latch. Okay. You don't care, obviously, so I'll just stop.
people who had them, but I never had one.
No. Like the thermos matched the design or the characters on there. Can't remember the character. All right, so shape a cylinder. We're going to fill it 1 inch from the top. All right, we're going to fill it 1 inch from the top with coffee. The height of this cylinder is 12 inches with a radius of 2.5. State to the nearest hundredth of a cubic inch. Be careful here. Hey, directions. The volume of the coffee. I don't care about the volume of the thermos here. I'm looking for the volume of the coffee in here. All right. So the coffee is 1 inch from the top. I'm looking for the volume of this right here. How much coffee is in there? All right. Don't give me the volume of the thermos. All right, well, when I pour the coffee in, it still takes the shape of a cylinder, doesn't it? So I can still use pi r squared h. I can still use that formula. Because when I pour the coffee in, the coffee's going to be in the shape of a cylinder. But there's one little catch here. Hopefully you guys see it. I'm still going to use 2.5 for my radius. But we're not plugging 12 in. That would be if I wanted the volume of the entire thermos, but I just want the coffee that's 1 inch from the top. So we're going to use what instead for our height? 3, Spence? 11, yeah. Right? 12 minus that 1 inch. Hundredth now. I'm changing the directions on you. Hundredth. What do you got for me here? 13? Try.
215.9.
Sounds good to me. Cubic inches of coffee. We all good? That was. Haven't seen our boy lately, huh? Get no homework. It's a shame. Oh, barrel full of oil is a right circle. Now, just so we don't get, if we ever see this on the homework assignments, that just means it's standing straight up. It's not a leaning cylinder. It's just the ones we're used to, the ones standing straight up here. Diameter. All right, we got a diameter of 22.5. And a height of 33.5. And there are 231 cubic inches in a liquid gallon. Determine and state the gallons of fuel that are in this barrel. All right. First of all, anybody see the word volume in this problem? I don't. So how do I know it's not surface area and not volume? Well, we're doing volume today. All right, but cubic inches, right? I see cubic inches tells me this is a volume problem. All right, so let's find the volume of the cylinder, and then we're going to have to convert that into gallons, it looks like. All right, find the volume, and we'll convert it into gallons. Pi, how about the radius here? Got to do a quick calculation. 6 radius. What does he get? 11.25. Yep. Squared, height of 33.5. All right, let's stress this right now. When you find the volume, is that my final answer? No, because we have to convert it. Why am I asking you if that's my final answer? Because I can't have you round it. All right, we got to write it all out here. Write it all out if it's in the middle of a problem. So 13,319. And that is cubic inches. Now we got to convert it into gallons, right? So I write my conversion. 231 cubic inches equals 1 gallon. Make a proportion out of it if you don't know what to do with the 231. I'm going to put my volume right underneath 231, put X underneath gallons, and we'll cross multiply. To the nearest tenth, it says nearest tenth, how many gallons of oil in here? When you're ready here. 4, when you're ready back there.
Uh, 57.7.
Got it. Hey, are we okay doing this? Because that's where I really need you guys to be. I honestly, great. I know everyone in here can find volumes. You just plug numbers into formulas and type it into your calculator. My thing is in here to raise the level in here to where it should be above average, doing something with the volume and converting it to a different unit. We're all good here? All right, and then how about this? Find the volume of this regular prism. You got to go back. What's the volume of a prism first? Let's take this one step at a time. Volume of a prism. 10, volume of a prism. pH, right? All right, here we go. And I don't expect you to do this, but I'm just doing it so everyone can see where every single number comes from. I'm going to go off to the side and calculate what the area of the base is. What is the base? What shape is the base? 10? Oh, here we go. We have a lot of practice in this. Finding the area of this regular hexagon. Let me see. I'll draw it out, I guess, over here. Hexagon, got it. Hexagon. There it is. Okay, can you guys help me find the area of this for me? This is just big B. Remember what we do. You. Have we memorized this by now? What's that angle? 60, 30, 60, but this is going to be 3 right down here. Because it cuts the 6 in half. What's the height going to be of that triangle? 5, what's my height?
3 radical 3.
3 radical 3, good job. All right, ready for the area? This is just big B again, just big B. I'm going to have everyone 6 triangles formed, right? That's where that 6 comes from, times 1/2. And this is what I get nervous of. What are you going to put for the base of this triangle? What's the base of this triangle? 11, 6, not 3, it's 6. So times 6 times the height Abbott just gave us, 3 radical 3. 3 radical 3. So that's all big B. That's all big B. Whatever that comes out to be, literally. what is that? 36, 18, 54. I'm just going to keep it as 54. I think it's 54 radical 3 in simplest radical form. So I'll just leave it. You guys probably did a decimal. Fine, leave it. That's going to be big B. I don't know what's going on here. I'm short circuiting here on the board. What's going on? Whoa, whoa, whoa. Okay, there we go. And what's the height of this prism? Height? 3. Spence? 8. It is. Yep. And then go ahead, everyone. Here's 100th now. Multiply that decimal you got from capital B. Where we go? Nearest 10th? 11. Kelsey, nearest 10th?
748.2.
What?
It says 100.
It does on yours? Okay, got me there. Nice. All good? All right, one. This is it right here today. What about these bad boys? I hate to break it to you, on your reference sheet, you will not find the volume of an L formula. Unfortunately, that doesn't exist. So what are we going to do instead? How about can we break it up into 2 prisms? Sure. And then do length times width times height. So I'm not going to do this one with you because I could break it up this way. Some people may break it up another way. So you break it up however you want and find the volume, both volumes of your prisms, and we should all end up with the same answer. So break this up into 2 prisms, length times width times height. All right, I decided to break mine up vertically like this. So if you did that, one volume for the bigger prism was 64, for the smaller one was 12. Either way, no matter how you broke it up, you should have got 76 cubic feet. All right. And then finally, 9, I have good news. Remember, surface area was everything that's not covered up. Well, volume, we're going inside, so I don't care what's covered up. It doesn't matter. Does not matter. All we're doing here, this is just going to be volume of a prism plus the volume of a half cylinder. That's it. You do not have to worry about what's covered up when you do the smash up problems. You do not have to worry about what's covered up. There it is, done. Because remember, you're filling up the inside. All right, so tell me, volume of the prism, what numbers are you going to use for those? 4, what number are you going to use for the prism?
11, 6, and 8.
11 times 6 and 8. Plus, here we go, half the cylinder. So pi, what would be the radius of that cylinder? Be careful here. What would be the radius of that cylinder right there? A couple different ways you could get to it. What's the radius length of that cylinder? 13? 4, right? I could either go 15 minus 11, gives us this right here, which is the radius, or if this is 8, this is 8, take half of it, you get 4 either way. 4 squared, and now times the height. This is where you got to listen to me here. Height is the edge that connects the bases. So if I'm looking at this figure, here's the edge right here that connects those bases. That's your height of the cylinder. How long is that edge? Because that's your height. 2, 11, finish it. 6. And then make sure we cut it in half. Okay, make sure we cut that in half because it's a half cylinder. And we're going nearest whole number. Nice job today. Finish strong. Finish strong. Finish strong. Anna, finish strong.
679 inches cubed.
Darn right. Did I still assign 5 problems? There you go. Yep, and make sure you know 18, the diameter is 11 there. Okay. Not much for the assignments nowadays. Just making sure you're picking it up.